It's flying in. I've got a dot, dot, dot. I've got a theta. I've got this, and I've got 5 miles over it. What do you want to call this variable here? We'll let Hummer pick it out. Hummer, what do you call this variable here?
Oh, hi.
Hi, how you doing? What do you call that variable here?
Height.
Height. H?
What is that, right?
All right, sorry, missed it. I thought you said hi.
Oh, I was saying hi.
Hi. Yeah. Sounds like hi again, but still. Height. Or H would be good. All right, moving forward. What do you got here? What are we going to call this variable then?
Angle?
No, this here.
Base.
Base.
Length.
B. All right, good deal. Good deal. That's fine. I'm going to call it letter B. Is that okay with you? For that's right, the whole word base.
No. All right, base.
You already said B, so we're going B. Okay, I've got theta here. All right, let's move forward here. I've got those. It says here an airplane flies at an altitude of 5 miles towards, so it's a constant 5 miles. And then it says 600 miles per hour. 600 miles per hour. With me so far? And then it says find the rates at which the elevation is changing. Angle of elevation. Go ahead. So, Pecorino, what do I know? I know the height's 5. Love it. Oh, wait. They have an angle there. I messed up. What's the first angle? 30 degrees? Which is pi over 6, right? Because we would never write it as 30 degrees. Yes.
I don't know that it's 60 miles per hour.
600 miles per hour? Is that there? Okay. That looks like that. What is that in terms of my variables? That would be B. So how did I write that? Because it's a change. It's a miles per hour. So how do we write that? dB dt is equal to 600 miles per hour. I'm not going to disagree with you just a little bit. Because if B is this, is it really increasing at 600 miles per hour? What is it doing? Ooh. Planes flying, floating in space. Which means B is doing what? By how much? By how much? If that's true, that means this is getting bigger. B is getting bigger. Is B getting bigger? B is getting what? Smaller by 600 miles per hour, right? So I'd put a minus sign here. Is that okay with you? That's huge. Lame. And then what am I looking for? D theta dt. Okay, I'm going to pause here. We'll let you guys play with it, see if you can find a formula. You get tangent because I got height, I got base, I want angle. It's got to be tangent. So I go tangent of theta equals h over b. Now, there's 2 routes from here. One of which is to note the height is not changing. So can I just put a 5 in here? Is that okay with you? Or we can do the quotient rule, and then the h will eventually cancel out and become a 5 anyways. We can put in a 5, as long as it makes sense. Why I can change out. Now the base is changing, right? It's getting smaller, but the height is going to stay 5 the whole entire problem. So I'm allowed to change that to a 5. I'm going to rewrite it so it's ready to be derivatized, as the other class likes to call it. We're going to take the derivative. How do I take derivative of tangent theta? Love that remembrance. 1 over cosine squared theta times d theta dt. Perfect. Now we're on it. And then this becomes negative 5 b to the negative 2 dB dt. So unfortunately, I need to know what b is. And that we did not solve for. So you need to go back and figure out what b is going to be. This is pi over 6. How am I going to figure out what b is? Well, I'm missing this side too, so I wouldn't use Pythagoras. Let me give you a cute little hint. Oftentimes, putting it back in the equation that you picked out is actually the way to solve for the variable you're looking for, right? Because I'm going to put it, if I put a pi over 6 in here, I can solve for what b is. Now, that, keep in mind, that means that on the next one, I'm going to have to do it again for the new angle, right? So I go tangent pi over 6 equals 5 over b. Tangent of pi over 6 is root 3 over 3. So if it's root 3 over 3 equals 5 over b, then it's root 3b equals 15. Or b equals 15 over root 3. So I'm going to have to shrink this down. So let me try that out. Is that okay? I shrunk that a little bit. Hard to see, but I need some more room. Okay, so cosine, this becomes 1 over cosine of pi over 6. That whole thing squared. D theta dt is equal to negative 5 over 15 over root 3 squared. dB dt, which is negative 600. I have everything I need to solve it. It's just going to be a headache. Cosine of pi over 6 is root 3 over 2, right? So this becomes 1 over the square root of 3 over 2 squared. D theta dt is equal to negative 5 over 225 over 3. Because I'm squaring top and bottom, times negative 600. Now, this is going to be 3/4, right? That's going to be 3/4. That's 1 over 3/4. So I'm just multiply both sides by 3/4 to get rid of it. Okay? So d theta dt is equal to negative 15 over 225. Did I flip that right? I did. Times negative 600 times 3/4. And then it's just a matter of grinding that up as a fraction or decimalizing because you've given up on fractions. How's that look? Got it? Why is the angle positive? Why is the rate of change positive? We'd be getting bigger, wouldn't it? It takes care of these things, which is fascinating. It knows. Math works. All right, simplifying this, I got 150 here. 3 to 225 would be 75, so that's 75 here. That's 150, so that becomes 2. Am I getting negative 30?
Yeah.
All right. Oh, positive 30, thank you. 30 radians per hour. I mean, you might think it's a large amount, but given that we're talking about an hour and a plane is going to fly overhead in about 2 minutes, the angle is going to change pretty radically, pretty fast, right? Especially if you consider an hour. Okay, good? Got it? All right, let's give you some more problems to chew on.